Hi, welcome to Imperium Learning. In this video we're going to be covering Granger Causality. If you didn't see the previous video, just to update you, that was a concluding video in a 5-video series relating to how to estimate and interpret a vector error correction model. Whilst a vector error correction model tends to look at the long-run relationships between variables, Granger Causality concerns itself with the short-run relationships between variables. In fact, actually, I just realised as well, which I forgot to do, when you look at your vector error correction model, you should also be doing some residual tests. So how do you do residual tests? You click on View, you click on Residual Tests, and then you're going to want to first and foremost test for autocorrelation. So we can start by doing the portmanteau autocorrelation test. Okay, so for this we'll just include 4 lags. That's an excessive number of lags offered there. And this is actually the, I think this is the Lung box test, yeah, because as you can see here, you've got your Q statistics here. So as you can see, the p-values are way above 0.05, so that's very fortunate for us. We can't really go much higher. In my particular case, we can't really go much higher than this because of the degrees of freedom. I only have 102 observations, so because of that, I'm not going lower than 4 lags. But as you can see here, that's very positive. We can also do the other. Let's in fact, I actually think I specified this one with 2. The reason being is to be consistent with the number of lags that I included for my vector error correction model. I included 2 lags for my vector error correction model, and so it's just keeping it consistent. And so as you can see here, I mean, let's actually just include 4 just to see what it looks like. That'd be quite interesting, just to see. I did. Oh, well, I think anyway, even though as you can see now that 4th lag actually does show that it suffers from serial correlation. I think so long as the number of lags is consistent with the number of lags that you've estimated in your vector error correction model, I think that should be fine. So yeah, I think 2 is fine. Doing the normality test, just clicking OK, you can see that there's certainly a problem here, because that means that the residuals of our vector error correction model are not normally distributed. And finally, applying the white heteroscedasticity test, you can see again this is problematic because the p-value is below 0.05, and seeing as the null hypothesis for this test is that there's no heteroscedasticity, this means that it does suffer from heteroscedasticity. Now, what would you do if you have this problem with your residuals? Well, the good news is, and I'll be covering this in a later video, what we can actually do in order to get around this issue of our residuals being failing certain important tests, I'm going to be doing this in a later video. We can actually take the equation that's most important to us, and remember we estimated a system of equations when we estimated a vecum. We'll take the one that's most important to us, which for me personally was this one because I was investigating house prices, and we can use this equation here to estimate a least squares regression and then do residuals on that least squares regression. I'm not going to do that right now though, because the topic of this video was supposed to be Granger Causality, so I'm just going to very quickly show you how to do the test and how to interpret the test results. So so bear in mind, actually I just want to introduce you to the concept very quickly before we actually apply the Granger Causality test on Eviews. So just bear in mind that this test involves examining whether the information provided by the lagged values of one variable allows for a more accurate prediction of another variable's present value. So as you can see, and this is a critical point here, this third bullet point, that Granger causality does not mean causation. Instead, it indicates that there's merely correlation between the past values of one variable and the present value of another. So if it's that being said, if it's found that variable x Granger causes variable y, then variable x could be used, albeit cautiously, to predict future movements in variable y. And so just to give you a brief summary of the test, you can see here that the null hypothesis is that variable x does not Granger cause variable y, and that the alternative is that variable x Granger causes variable y. So in other words, when we apply this test on Eviews, we'll be looking at p-values of less than 0.05 in order to be able to conclude that a variable Granger causes another variable. And finally, when we analyze these short-run relationships, we should be we can either describe these relationships as unidirectional, bidirectional, or neither, and neither meaning that they're independent of each other. And so so yeah, I'm just gonna show you how to do it very quickly. You click on View, you click on Lag Structure, and then as you can see here it says Granger Causality. Now as you can see here, and this one in particular I was quite interested in because that would mean I could look at the lagged values of my independent variables, the money supply, credit, interest rate, or the unemployment rate, in order to see if those would be good predictors of future values of the average house price. Unfortunately, as you can see, the all of the p-values are way above 0.05, so none of them Granger cause the average house prices, and at the same time jointly they don't Granger cause house prices either. You could make an argument maybe for this, just as as an example very quickly. You can see that the p-value is below 0.1, so you could say at the 10% significance level it Granger causes the money supply, but again it's only a very weak argument because the p-value isn't below 0.05. And just scrolling down, you can see finally here we have one that's below 0.05. That means we could say that the lagged values of house prices actually help us to predict credit. Now actually I just want to wrap up the video here. I'm going to conclude this video on Granger Causality in another very short video, because I do just want to really make sure this is explained well. So I'm going to wrap up the video here. Okay, bye now.